Truck moving at 10 meters per second approaches a stationary car. The truck has 3 times the mass of the car. It doesn't matter what the mass is. Truck has mass 3m, car has mass m. So the question is, where's the center of mass when the two are 100 meters apart? Well, if you haven't answered that question, you should without looking forward. The answer turns out to be 75 meters from the car. Reason being, well, let's imagine the truck and the car being balanced on some kind of a light supporting beam. The truck being 3 times the mass of the car will exert 3 times the torque on the system if it's at an equal distance. If the distances are in the ratio of 3 to 1 this way, car with 3 times the distance from the fulcrum, the truck as opposed to the truck, then the system will be in balance. So if this distance is x, this distance will have to be 3x, which basically means you can cut this interval into 4 pieces. 3 of them will be between the car and the fulcrum, 1 of them between the fulcrum and the truck. Now you can set that up with a formal equation, but the intuitive idea is pretty clear, and we're not going to use any more than just that. So the answer in this case would be, if the two are 100 meters apart, the truck is, or the center of mass is 75 meters from the car. Now when they're 60 meters apart, the same reasoning leads us very easily to the conclusion that the center mass is 45 meters from the car. So the question now, does the center of mass approach the car, the truck, or both? Okay, so you ought to think about that, but the answer is both. The center of mass moves in this direction, so it's clearly approaching the car, and it goes from 100 meters to it goes from a position 75 meters from the car to a position 45 meters from the car. It's clearly approaching the car. And you can also reason out that the distance from the truck is decreasing, so the center mass is also approaching the truck. Then the question is, how fast is the center mass moving? And it's easy to see that in this, just between these 2 points, the truck moves 40 meters while the center mass moves 30 meters. Truck moves from 100 to 60 meters from the car. Center mass moves from 75 to 45 meters relative to the car. So 40 centimeters here, 30 centimeters here. So the speed of the center mass is 7.5 meters per second. And we know that relative to the car, that 7.5 meters per second is approaching the car. It's in the same direction as the velocity of the truck. Now, we can use the subscripting to understand what the answer to the next several questions. Now, the next question was, what's the velocity of the truck relative to the center of mass? Or what's the velocity of the center of mass relative to the truck? Center of mass is moving this way, but not as fast as the truck. So the truck is catching up to the center of mass. So relative to the truck sees the center of mass approaching it. If the center mass was a tangible object, or if there's some tangible object moving along with the center of mass, the truck would see it getting closer. So the velocity of the center mass relative to the truck is negative 2.5 centimeters per second, provided that the positive direction is that of the 10 centimeter per second velocity of the truck. So the velocity of the center mass, as seen from the truck, is in this direction, negative 2.5 meters per second. The velocity of the car relative to the truck is what? Well, the truck sees the car coming at it at negative 10 meters per second. The velocity of the car relative to the center of mass. If you're riding the center of mass, you're moving along with the center of mass again, you see the car approaching you at 7.5 meters per second, this direction being negative. That's also negative. We can use kind of a transitive property of the subscripts to formally write this down. The velocity of the car with respect to the truck is the velocity of the car with respect to the center of mass plus the velocity of the center of mass with respect to the truck. You should use this example to convince yourself of why we have this rule for subscripts, okay? It's almost like these are fractions, c divided by cm, cm divided by t. You multiply those fractions, you get c divided by t, which is this. You're not multiplying fractions. This has nothing to do with the rules of arithmetic, but it still works the same way. So that's a convenient way to remember how it works, but you should understand as deeply as you can why that works. You should visualize it as best you can, because it'll give you more power to solve problems, more power to visualize. But of course, it's also important to symbolize. Okay. Now, the velocity of the center mass. Okay, well, the question arose. After collision, if these things collide in an inelastic collision, then how fast are they moving after collision? Now, people didn't answer that very quickly because you've gone to equations and working things out. And those equations are easy enough to solve. However, there's an important insight here, and that is that the velocity of the center mass is constant. That's before and after collision. Common velocity. So this is easy to show. It's a very important property. And it comes from the assumption, of course, that there are no external forces. The only forces involved are the forces between the two objects. So the common velocity after the inelastic collision, in any case, has to be the velocity of the center of mass. And the camera's not aimed low enough to see that. We also get that calculation of the velocity of the center of mass here that apparently was not visible before. Okay, in any case, velocity of center mass after collision is the same as the velocity before, so we just use VCM for both. Now we can apply that more specifically to an inelastic collision. We can also apply this principle to an elastic collision. The velocity of center mass stays the same in an elastic collision as well as in an inelastic collision, or anything in between, again assuming that the only forces are those between the two objects, the equal and opposite forces exerted by the objects on one another.